All right, so for today we're doing section 11.1, and what we're going to be working on is the probability stuff. Okay, so eventually we're going to get into combinations. That's tomorrow, I think, or maybe it's permutations. I forgot which one we do, but we'll do permutations and combinations. We'll talk about what those are. But before we can do those, we have to understand counting principle. Now, the counting principle is pretty easy. It's just basically the question they're going to ask you is how many ways can you do certain things? Okay, so how many ways can you choose a shirt if you have 10 of them, right? So, well, there's 10 ways to choose one shirt if you have 10 shirts, right? How many ways can you pick a pair of pants if you own 5 of them? Well, 5 different ways. I can pick this pant or this pant, right? I can pick a certain number. So it depends on what we call our sample space, okay? So the sample space is, let me define that for us, the total number of ways an event can occur. Now, the word event is the key part right here, because event basically means what you're trying to do. So maybe you're trying to flip a coin, so the event is flipping a coin. Maybe you want to pick a specific blue marble out of a bag of marbles, right? So the event is picking a blue marble, right? So we'll talk about that as we do the examples. But the sample space is just the total number of ways an event can occur. Okay, so the event will be described to you. So look at example number 1. It says find the number of possible outcomes in the sample space. So remember, don't get scared by the word sample space. That just means like figure out how many ways something can happen, right? How many ways can you do specific things? Now, I will tell you that when you're trying to do these counting principles, it helps when you use underlines. Okay, so I'll show you right here in the first example what I mean. Okay, that way you know, like, okay, they said that someone's going to shoot 3 free throws. So that's 3 underlines because each underline is a shot, right? So he shoots it once, shoots it twice, shoots it 3 times. That's one event, one event, one event, okay? Maybe rolling a die, right? That can be an event as well. So let's look at the first example. It says example number 1, find the number of possible outcomes in the sample space. Part A says picking any 3 letters from the alphabet, okay? So picking any 3 letters in the alphabet. So how many events are going to occur here? Well, there's 26 total letters, but how many events? 3, because how many times am I going to pick a letter? 3 times. So there are 3 events in this problem, okay? And what you're going to do is you're going to multiply your number of ways that it's going to give you. And unfortunately, so sorry about that. So we're going to do 3 events. So we're putting 3 underlines, right? The first underline is the first time I picked the letter. The second underline is the second time I picked a letter. And the third underline is the third time I picked a letter. Okay? So how many different ways can I pick a letter from the first one? You said 26, right? How many different ways can I pick a letter the second time? 26. Now, what if they would have said I can't pick the same letter? Then there's only going to be 25, right? So, but for us, we're going to do 26 because they didn't say you can't repeat it, okay? And then for the third pick, how many ways can I pick a letter on the third one? 26. Again, they didn't say that I couldn't repeat. So your answer for this example is basically 26 to the third, or 26 times 26 times 26. That's 17,576 different ways, okay? So if I were to tell you, I want you to pick 3 letters from the alphabet, that's how many ways you can do that. 17,576. You could say like, okay, AAA, that's 1. BBB, CCC, DDD, EEE, right? And then you can eventually, once you're done doing all 3 of the letters individually, you can be like AAB, AAC, AAD, AAE, AAF, AAG, right? And then do that with ABA, ABC, right? So doing all those combinations, if you had to write them all down, there'd be 17,576 ways. Now, just out of curiosity, I'm going to change the color because I'm going to kind of create a different problem. I'm not going to write it down, but I'm going to create a different problem. What if what I mentioned earlier was the case? Pick a letter from the alphabet, 3 letters, but don't let them repeat. So the first one would be what? 26. And we said the second one would be 25. What would the third one be? You only have 24 options, because if you already picked A and B, you can't pick them anymore. So how many letters are left? Well, only 24, right? So if I were to multiply that, 26 times 25 times 24, that comes out to 15,600. Okay? So that's how many ways you can pick a letter from the alphabet without repeating. So then they can ask you, well, how many different repetitions are there? Well, you can look and say, well, there's close to 2,000 repetitions, right? Because if you look at the difference between 17,576 and 15,600, that's about 2,000, right? Roughly. So you know there's about 2,000 times that they repeat. Letters at least will repeat once, right? So, all right, no problem. What about flipping a coin twice? So how many ways can you flip a coin 2 times? How many different results can you get? Right? Well, first let's that's the total number of results, because you can either get heads or tails, right? You never like heads, tails, or flat, like on its edge. No one ever says on the edge, even though that's a possibility, by the way. There is a very small possibility that when you flip a coin, it lands right on its side. Okay? But no one ever says that. We always say 2, right? There are 2 events, flipping the coin once and flipping the coin the second time, because they said flip it twice. So I have 2 events, flipping a coin and then flipping a coin. Now, as you said, how many different outcomes can I get from flipping a coin? Well, heads or tails. So that means 2, right? And then I flip it again. How many outcomes do I get? 2 again. So there are 4 different results you can get from flipping a coin 2 times. We can list them. You can get heads and heads, tails and tails. You can get heads and tails, or else you can get tails and heads. Those are your 4. Okay? 2 heads, 2 tails, heads and tails, or tails and heads. Now you might say, well, heads and tails and heads, isn't that the same thing? They both came out to the same thing. Well, yeah, but one of them came out first, the other one came out second. Okay? So order kind of does matter in some situations, in different ways that they can come out. So, I mean, again, this isn't terribly difficult, right? This is counting principle, just figuring out how many different ways something can occur. We're not trying to do like percentages or anything like that. Just we're trying to figure out the number of ways that something can happen. And let me dismiss this. All right, so guys, those of you guys that were taking the test right now, you need to put those notes away and continue with your quiz. Okay. But notes away for those, what was it, 3 or 4 of you guys? So hopefully you wrote down all the formulas you needed, etc., and just continue. Are we okay so far with part A and part B? You want to do it, but you're not going to have the, all right, so moving on. Rolling a die 3 times. Okay? I'm rolling a die 3 times. If you don't know what a die is, it's dice, but it's just 1, right? So you're looking at, this figure here, right? There's a 1, a 2, a 3 here, right? So that's what we're doing. We're going to roll it 3 different times. How many sides does a die have? It has 6 total sides, right? So they want me to do it 3 times. So the event is rolling the die. And they said do it 3 times. So I'm going to have 3 events. Okay? 1, 2, 3. Now the first time I'm going to roll the die, it has a possibility of 6. If I roll it 2 more times, okay, what are going to be my options if I can repeat the number? 6, a 6, and a 6, which comes out to, I don't know exactly what that is. Okay, thank you. So 216. Now, what if I asked you, roll a die 3 times, okay? Now, let's think about it. I'm going to mess around with you guys here. The first one, it can be any number. I'm going to put any. How many ways can I do that? Any number when I roll it? 6. Okay. The next one can be numbers less than 3. Okay, so I'm going to put less than 3. How many ways can that happen? 2, only 1 and 2, right? So 2 ways. And the next one, let's say an odd number. So there's 1, 3, and 5 only, right? So if I were to ask you, roll a die, and the first time you roll it, it can be any number you want. But the second time, it has to be a number less than 3. And the last time, it has to be an odd number. Then your total number of ways that can happen is 36. Notice how much less of a sample space we have, right? Outcomes that we have. Because I got very specific. Before it was just like, who cares? Just roll it. Any of the 6 numbers will work. Roll it 3 times. So we got 216 ways that can happen. But then when I said, well, first time you can just roll it. But then, hey, maybe odds only and numbers less than 3. Notice how small the amount of ways that can happen. 36. Right? So now, by the way, just so you know, when we ask you what's the probability of the top thing happening, that you roll any number, that the second row is less than 3 and the third row is odds only, it's going to be 36 out of 216. That's how you create the probability. You get the total number of ways that goes in your denominator. Okay? And on the numerator, you put your specific situation. So the number of ways, less than 3, odds, that's being specific. So you put the 36 on top of the 216 and you divide it. And if we were to do that, but we're not doing that today, don't worry. But if we were, the answer comes out to 16%. There's a 16% chance that can happen when you roll a die. Okay? So that's how we find probabilities. We get our specific and we divide it by the total amounts, by the sample space. Okay? So anyway, the green part again is not part of my example. It's just me creating something different. The red one is our example. All right, here we go. Part D. Now, I don't know if you want to write down this whole thing. It's up to you. But it says a pizza shop offers 2 types of dough, wheat and white. They offer 3 types of toppings, pepperoni, sausage, and mushrooms. How many possible combinations do they offer? Now, you've probably heard Pizza Hut, and I think Domino's, they do this. They'll be like, with over 150,000 combinations, right, of pizzas you can get. Well, yeah, I mean, how do they figure that out? Well, they say, how many pizza doughs do we make? How many cheeses do we make or put on? How many toppings do we put on? Okay, add those all up. Okay, great. Now let's create a counting principle, and we'll tell people how many different ways we can create a pizza, right? So right here, we're gonna create a pizza. We have 2 choices of dough, 3 choices of toppings. How many possible combinations do they offer? So what's my first event in ordering this pizza? The dough. So that's the first event. I'm going to write right here, the dough. Right? What's my next event? The toppings. So there's only 2 events happening, right? I got to pick the dough. I got to pick the number of toppings. So the dough, I have too many. How many options do I have? 2. And then how many toppings? 3. So how many different ways can I create a pizza? 6 different ways. Okay? So I always mess around with my youngest daughter because she always talks about she doesn't have any clothes to wear, right? And every time she says she doesn't have too many clothes to wear, I say, how many shoes do you have? She says, I don't know, like 5 or 6. I'm like, let's just pretend you have 5. I said, how many shirts do you have? She's like, I don't know, like 10. I'm like, all right, let's just say 10. I said, how many sweaters do you have? She's a thrifter. She's like, I don't know, like 30. I'm like, okay, pants, I don't know, like 10. I'm like, multiply all that stuff out. And then she starts getting really upset because she's like, why do you have to make everything math? I said, you got 15,000 combinations of clothing. What do you mean you don't have anything to wear? Well, you got 15,000. This comes out to 15,000 different combinations, right? I'm like, you never have to wear the same thing twice for 15,000 days. That's how much you have. So like I said, just like with pizza, if we were to pull up the Domino's menu right now, I know that they offer a couple different types of doughs. I know that they even offer different things to put on the sides of the dough, garlic, whatever. You can stuff it or not. And then you have the different types of cheeses. You have the different types of sauces. You have I mean, no wonder they have like almost millions combinations, right? You can make a bunch of different types of pizzas. So there you go. But this is just a little small, right? We don't have to get too crazy. All right. I think we got 2 more of these and then that's it. But you can see these aren't really that difficult to do, right? It's just, you got to just figure out the events you're dealing with. Now we have a band and they're going to meet up for practice. The possible days that they can meet up are Tuesday, Wednesday, or Thursday. And the possible times are 3 or 4 p.m. Okay? How many ways can they try to decide their options? All right, so what's my first event here? The day, right? What's my next event? Time, okay? How many days do I have in options? 3, and then how many times? So yet again, 6 different ways. It could be Tuesday at 3, Tuesday at 4, Wednesday at 3, Wednesday at 4, Thursday at 3, Thursday at 4. 6 different ways. But I don't have to worry about doing that, what I just did, like think it through. I can just say 2 ways to do this, 3 ways to do that, so it's 6. 6 different ways. Right? So here we go, last one. So a softball player bats 4 times in a game. Each at-bat results in an out, a hit, or a home run. Okay, how many outcomes can they have? So how many events? 2? Not 2. 4 events. In the first part of the sentence it says they bat 4 times. So they're going to go up to the plate 4 times. 4 events. Okay? So 4 events. Now, in each event, how many things can happen? 3. They can either get a hit, they can get a home run, which I guess is a hit in a sense, or they can get an out, right? Every single one of these has an option of 3 because those 3 options can occur at every at-bat. So I just multiply 3 times 3, 3 times 3, that's going to be 81. That's 81 different things that can occur at 4 at-bats. Okay? So there you go. This is what your homework is going to be like. It's just going to give you some situations. You're going to basically create, I would recommend, you don't have to, but I always recommend underlines to, once you know how many events, put little underlines there. That way you know, okay, it's happening 2 times, 3 times, 4 times, and then we figure out the options for each underline, okay? You don't have to do it. This is just the way I do it. It's usually the easier way because it gives you a guide, okay? All right, let me give you guys the homework and let me stop this thing.